A monster is waking up in California. Beneath the granite peaks of the eastern Sierra, something has begun to stir. A section of the Earth's crust, 10 miles wide and 20 miles long, is bulging upwards. The ground is shaking, not once or twice, but thousands of times a year. And a strange invisible poison is leaking from the soil, killing acres of ancient forest. The headlines have already been written. The alerts have been drafted. 3 million people, from the ski slopes of Mammoth to the suburbs of Los Angeles, are living in the shadow of what is being called a death zone. But here is the detail that tells the real story. The caldera has not cracked open. There is no official death zone alert for 3 million people. The story being told online, in panicked whispers and viral videos, is not the story that is actually unfolding on the ground. The truth is not a story of imminent apocalypse. It is something far more complex, and in many ways more unsettling. It is a story about a very real, very ancient power, and how we choose to live beside it. The most dangerous thing about the Long Valley caldera is not the magma churning miles below, but the mythology we have built on top of it. To understand what is happening, you have to understand the place. Drive east from Yosemite over the Tioga Pass, and you descend into a landscape that feels primal. This is Mono County, California. It is a land of extremes, of high desert and snow-capped ranges. And nestled at the foot of the Sierra Nevada is the town of Mammoth Lakes. Population 8,000, elevation nearly 8,000 feet. People come here to ski, to fish, to hike. They drink coffee on Main Street and watch mule deer wander through their yards. They are living, working, and raising families on the southwestern rim of one of the largest volcanic calderas on Earth. It's a strange thought, living a normal life on top of something so monumental. I'm actually curious what you think about that, about the choice to live in a place with that kind of hidden power. Let me know below. The caldera itself is not obvious from the ground. It is too big. You feel it more than you see it. A vast, shallow basin stretching for 20 miles. It is ringed by the evidence of its violent birth. To the south, Mammoth Mountain, a cluster of lava domes that makes for one of the world's premier ski resorts. To the north, the eerie volcanic chain of the Mono Inyo craters. In the center, a resurgent dome, a blister on the caldera floor where the ground has been pushed up from below. This entire landscape is a scar left behind by an eruption that defies human comprehension. Zoom out and the timeline becomes geologic. Exactly 767,100 years ago, this tranquil valley was the site of one of the planet's largest known explosive eruptions. A colossal magma chamber, which had been growing for millennia, reached a critical point. The roof of the chamber fractured. In a matter of days, perhaps hours, a plume of ash and superheated gas rocketed miles into the stratosphere. It was a VEI 7 event, a cataclysm on a scale so vast it has no modern equivalent. More than 600 cubic kilometers of material were blasted out of the earth. Pyroclastic flows, incandescent avalanches of gas and rock moving at hundreds of miles per hour, scoured the surrounding landscape for dozens of miles in every direction. When the eruption ceased, the now empty magma chamber collapsed in on itself, creating the 17 by 32 kilometer depression we now call the Long Valley Caldera. The fallout was biblical. A blanket of hot ash, hundreds of feet thick, smothered more than 2,000 square kilometers. This deposit, known today as the Bishop Tuff, can still be seen in the carved canyons and sculpted cliffs of the region. Traces of its ash have been found as far away as Nebraska and Kansas. For centuries, the planet would have felt the effects, a volcanic winter altering global climate, that is the history sleeping beneath the ski lifts and condominiums of Mammoth Lakes. That is the ghost that haunts the conversation every time the ground begins to shake. And in the late spring of 1980, the ground began to shake violently. On May 25th, a magnitude 6.4 earthquake struck the southern margin of the caldera. It was followed by a 6.1 and another 6.3 in the next 2 days, part of a swarm of thousands of smaller tremors. This was not a singular event. It was a sequence. It felt different. For the scientists at the U.S. Geological Survey, it was an alarm bell. They knew the history of the region. They knew what a swarm of earthquakes beneath the caldera could mean. It could mean magma was on the move. This is the part the headlines do not capture. The fear that swept through the community and the geological community in 1980 was real and justified. The USGS scrambled, deploying new instruments to get a better look at what was happening underground. And what they found was startling. A section of the caldera floor, the resurgent dome, was actively swelling. It was rising. Over the next 2 decades, from 1980 to the late 1990s, The center of the caldera would bulge upwards by nearly 80 centimeters, almost 3 feet. That is not tectonic shifting. That is the roof of a house bending because something is pushing up from the basement. A new body of magma, a smaller batch, had intruded into the plumbing system deep beneath the caldera. The USGS issued a notice of potential volcanic hazard. It was the lowest level of alert, but the word volcanic changed everything. Property values in Mammoth Lakes plummeted. The tourism-dependent economy faltered. There was a tense public standoff between concerned scientists trying to convey a potential risk and terrified residents and business owners who saw their livelihoods evaporating. A new agency was formed specifically to watch the monster, the Long Valley Observatory, or LVO, led for many years by USGS scientist Dr. David P. Hill. For the first time, this ancient caldera had a team of full-time human guardians. Now, here is the part nobody is putting on the news. The part that dismantles the death zone narrative and replaces it with science. What did all that sophisticated monitoring, deployed in a panic in 1980 and refined over the next 40 years, ultimately reveal? It revealed that the immediate threat was not what everyone feared. Decades of research, using techniques like seismic tomography, which acts like an MRI for the Earth, have given us an unprecedented picture of the magma chamber that caused the Great Eruption 767,100 years ago. And the verdict is in. That massive chamber is almost entirely crystallized. It's mostly solid rock now. The USGS puts it plainly, stating that the reservoir is unlikely to produce large-scale eruptions in the future. The engine of the super-eruption has run out of fuel. It cannot happen again from that same source. The frequent earthquakes, they are largely a product of a different force. The entire eastern Sierra is being stretched and pulled apart by tectonic forces, causing the Sierra Nevada mountains to rise and the basin to drop. Most of the quakes that rattle the coffee cups in Bishop and Mammoth are part of this ongoing regional faulting, not the upward movement of magma. The scientists at the Long Valley Observatory and Caltech's Seismological Laboratory have become incredibly adept at telling the difference. They can distinguish the sharp, high-frequency signature of a breaking rock fault from the lower-frequency, harmonic tremor of moving fluid magma. And for years, the soundtrack of the caldera has been almost entirely the snap and crackle of tectonics. The science and the people dedicated to watching this system 24/7 are frankly extraordinary. The work they do gives us the ability to separate fact from fear. You can subscribe if you want more deep dives like this. 1. Where we break down the reality behind the headlines. So if the supervolcano isn't going to blow, why did the ground swell up by 3 feet? And more importantly, what is the real danger? The 1980s uplift was caused by a much smaller, deeper injection of new magma, a pocket of molten rock that found its way into the plumbing system, but never came close to the surface. It was enough to pressurize the system, swell the ground, and warm up the shallow hydrothermal network. But it wasn't the prelude to a cataclysm. It was a geological sigh, not a roar. But that event did reawaken something else, a far more subtle and insidious threat. In the 1990s, rangers and hikers began to notice something strange on the flanks of Mammoth Mountain. Trees, huge centuries-old red firs and lodgepole pines, were dying. Not from disease, not from drought, not from fire. They were dying in distinct, isolated patches, their needles turning brown and dropping to the forest floor. The largest of these areas, near Horseshoe Lake, eventually covered over 170 acres. The ground felt wrong. It was a ghost forest, silent and sterile. Scientists, including USGS geochemist Dr. William C. Evans, went to investigate. When they tested the air at soil level, they found the answer. The concentration of carbon dioxide was lethally high. In some places it was over 90%, replacing all the oxygen in the soil. The magma intrusion of the 1980s had disturbed the plumbing system, releasing a massive reservoir of volcanic gas that had been trapped deep underground. This gas, mostly CO2, which is heavier than air, was now seeping up through faults and fissures. It pooled invisibly in the soil, suffocating the roots of the trees. It collected in snow pits, in depressions in cabins and basements. This became the real, present danger of Long Valley. Not a miles-high ash cloud, but an invisible, odorless gas that can kill a person in minutes. Warning signs now dot the landscape around Horseshoe Lake and other geothermal areas. Danger, CO2 gas hazard. Stay out of low-lying areas. There have been fatalities. Animals have been found asphyxiated. It is a danger that requires constant vigilance. especially in winter when a thick blanket of snow can trap the gas and turn an innocent-looking hollow into a deadly trap. The threat isn't coming from a fiery explosion, but from the mountain's own silent, toxic breath. This is a story about the complicated relationship between perception and reality. It's what makes this topic so endlessly fascinating. If you know someone who worries about this stuff, maybe send this video their way. Understanding the actual risk is the first step to managing it. The system of surveillance watching over this breathing mountain is one of the most advanced on the planet. This is not 1980. Today, the caldera is wired. More than 50 state-of-the-art seismometers listen for every rumble. Over 30 high-precision GPS stations measure ground deformation continuously, capable of detecting changes smaller than a dime. Satellites using a technology called INSAR radar scan the entire region from space, creating millimeter-scale maps of uplift or subsidence. An array of sensors constantly sniffs the air, measuring the output of CO2 and sulfur dioxide, another key volcanic gas. The water chemistry in hot springs and streams is regularly tested. All of this data flows in real time to the California Volcano Observatory, or CALVO, the successor to the LVO. A dedicated team of scientists watches these streams of information 24 hours a day, 7 days a week. They have established a clear 4-tiered alert system familiar to anyone living near an American volcano: normal green, advisory yellow, watch orange, and warning red. For its entire modern history of monitoring, despite all the earthquake swarms, the ground deformation, and the gas emissions, the Long Valley caldera has remained at the lowest level, normal gene. The death zone alert exists nowhere but in the frantic imaginations of content creators chasing clicks. The reality is one of sober, constant, and reassuring vigilance. But it would be a mistake to say there is no volcanic risk at all. The super eruption may be off the table, but the Long Valley system is far from dead. The most likely source of a future eruption is not from the caldera itself, but from the much younger, more restless system right next to it, the Mono Inyo Crater's volcanic chain. This is a 28-mile-long string of over 35 vents, craters, and lava domes that stretches from the south of Mammoth Mountain all the way to the north shore of Mono Lake. And it is geologically an infant. While Mammoth Mountain last erupted around 57,000 years ago, the Mono Inyo chain has been active repeatedly in just the last few thousand years. The most recent series of eruptions in this chain occurred only about 600 years ago, forming Poa Island and the Nejet Island Dome in Mono Lake. In geologic time, that was yesterday. According to the USGS, the most probable future eruption in the region would be a small to moderate event somewhere along this chain. It would likely involve sticky, viscous rhyolite magma, creating explosive steam-driven blasts, followed by the slow extrusion of a lava dome, or potentially more widespread ashfall if the eruption is more energetic. It would be a serious disruptive event for eastern California and western Nevada. It would mean evacuations, ash-covered ground, and significant economic impact. But it would be a local disaster, not a global one. It would not be a super eruption. It would not create a death zone for 3 million people.